people are saying, put AI everywhere. You're going to fall behind if you're not doing AI, if you're not figuring out how to leverage this new technology into your processes and into your business. And this creates, sometimes we used to joke this was kind of the golf effect, but it is really, in this case, has the possibility, if used correctly, to make huge changes, either in costs or in agility or other areas. So I'm going to base this talk really on the PDCA, the plan, do, check, act cycle. And just because the problem with that, the notion of do something everywhere is you panic and everybody tends to go to a couple places. And the question is, can you build kind of like the way you do for threat modeling or for other kinds of modeling, FMEA, failure mode analysis, right? Is there some scaffolding you can set up in place that would give you an idea where to put your AI everywhere? So I'm going to loosely base it on the PDCA cycle on the left and give the notion that we have a plan, a do, a check, and then we've got some other stuff. I'm going to talk about this in the software space. And so some of those ones on the left are actually going to get merged together. So, how do I get organized and go, hey, here's my business process. Here's what we do. Where does AI slot in a little bit? And so in my mind, this in the software industry anyway, and actually engineering or a lot of business process, there's a design time, there's run time, then there's analytics. That's the check, right? So design time is out of band for the customers. That's kind of what we do on the side. Runtime is what we do as part of our business process. So in my case, that's run code. And then we have analytics, which means we could use, this is kind of out of band with the customer and sort of after the fact. Could be while it's running. So we're going to pretend it's not the same thing as runtime because no customer data dies if the analytics thing didn't work right. But the whole system could go down if the analytics aren't right. So I don't know. Anyway, and then the last one is manipulate. So manipulate for me, so two of these have the warning logo on them. Oh, let's make the warning logo flash, right? Why do we have a warning logo on those? Because the customer data is actually touched inside those possibilities. So to my mind, a lot of people are like, man, I'm just going to AI, blah, blah, blah. A couple of things happen. High volume AI transactions like LLMs and those kind of things are really expensive, right? Search engine that's like started off at 10 times more expensive to do a web search for a search engine company to do the LLM version versus their current index model, right? So they're all about trying to optimize that to give the AI functionality without 10 times the cost. So you always got to be cautious, right? There are still a lot of processes that it's just cheaper and faster to just build it, do it, and not go try and stuff an AI into it. But there are other places where there's a big win. Okay, so let's look at design time. So let me give you an example of, so I'm here, man, I was told to do AI everywhere. I'm going to attack this from the top down. So one of them would be planning, right? So I've seen it where people convert, they take the product definitions or the requirements and they convert that into a backlog, right? So this is actually popped off the screen. Sorry about that. But so like if you did requirements using AI, or maybe you don't build the requirements using AI, you parse the requirements using AI. I've seen it also where we define business rules in a backlog, and those rules are used by an LLM to do code gen, right? So that's actually what I want to talk about real quick. So another one here is we can create models, data models, those kinds of things. I actually did this in a project I was working on. And another one is we can do code gen. So for design time, there's the planning part, there's kind of the definition, maybe there's the mock-ups. We're going to use LLMs to try and get a mock-up done faster. You still got to watch that. And then we're going to create things like we can give prompting and do code gen, or we can do prompting and change the data model, right? Now, we still have to put controls around this, make sure we don't break anything. There's a lot of work with that. But the beauty of the design time is humans are already involved. We might be able to reduce the amount of human effort or be more agile or do a better job. But the point is no customer electrons were destroyed by accident in the design time, right? And then if we look at the runtime, so to my mind, the runtime, and so we have all these, like I saw one the other day, somebody said they would create a requirements document got read by an AI. That generated the planning backlog, and it also generated some compliance documents, right? And then we talked about maybe defining rules, business rules with that. So we would run code gen off of the requirements to try and generate the business rules. So if we look at runtime, runtime is where the electrons are happening. It's where the primary expense, not really, but like a lot of the expenses and where a mistake can cause reputational risk, and it can cause business fiduciary risk, right? So to me, this is kind of the riskiest area in a lot of cases. The primary thing right now people are doing here is the agent, right? Can I open this without? Yeah, that didn't do too bad, right? And so where's the agent risk at runtime? Like an agent, hey, there's reputational risk, of course, and that's from the chat side. Hey, the agent told me that I get this discount, and discount never showed up, and it turned out the agent was wrong, right? The chat bot, right? And the other thing we can do in this runtime is we can go off and query other systems, and we can also invoke business functions to cause things to happen. And if you think about it, one of the things about agents, so there's regulatory risk. You have to decide, you have to be able, in some industries, be able to describe why you made a decision. And if you're like, my AI did it, that might not stand up. It might. You also have a bunch of issues around like maybe repeatability. You might get different answers if you ran the same request multiple times. But chatbots are a really good example of where work's being done in runtime. And a lot of times people really go after read-only functionality first, because that way they can't break anything, right? They might cough up the wrong data, but that's still better than corrupting something. I changed the flight path of this airplane because I queried the flight path, but no, I had my chatbot. No, like if I was doing air traffic control, I probably wouldn't do airplane routing. So anyway, with it, on the modification side. Anyway, so you get the idea, right? We talked a little bit about design time. That's kind of the planning part of the loop, right? And when we get bad measurements or different kinds of measurements, we'll make changes in that design time. And then we have the runtime space, right? And again, I said this is probably the riskiest place right now. What was I thinking here? What did I put in here? Oh, decisions. So this would be like I have a business rule engine, or I have some kind of decision tree on what to do based on LLM work. Again, you got to decide where the AI makes sense and where it's way cheaper in some cases and way more deterministic to do something else. So the design time, I think there's a lot of movement in that space. The next one would be analytics, right? And so this is a good example where something like I want to do alerting based on, I think that this AIs might be better at pattern recognition than you'd be able to train. And so they might be able to find a cyber attack, for instance, right? Or you might be able to find, I'll give you a really good example. One of the cases we really suffer with in a lot of places is if a system partially goes down and traffic goes down on a channel, but the total traffic still looks pretty good, and the traffic is pretty cyclical, right? Has a wide range of motion. A lot of times you can't tell that some part of a service is partially down, right? So you might be able to use AI to do pattern recognition or do other things, and that would be an example where you found something was down. Now, whether you took automated action remediation and did a runtime change, that's up to you, but at least you could do alerting or other things, and then you could decide whether you wanted to integrate that later. A lot of the cyber companies are trying to get reasonable models because they're deterministic models around. They want to be able to predict a failure, an attack, and not pick it up because they've seen that attack before, right? And so that's a good example. So the last one is one I'm looking at personally, which is the using AI to manipulate data outside of the runtime. And so in my case, this would be to actually repair data. Hey, we have a situation, we had a problem in an app, and it did this to the data. We would like to have all these data apps touched, and here's 2 examples that we fixed. Can you fix the rest of these? Now, I do have the blinking light of doom here, and that's really because any place we change the data without human intervention, that's possibly bad. So in this case, what we might do is we might try and apply that kind of fix from some corruption thing, and then we would maybe have humans analyze it or run it through some kind of post analyzer to see if it got fixed. I've seen some where you can do fairly complicated transactional semantics, and they're really hard for people to fix, but maybe with some AI assist, we could make that happen. We could even try and do that, but if you corrupt them, man, you could end up in some kind of major problem. So anyway, so that's where I'm at, right? When people say do AI everywhere, the question is, how do you create a scaffolding to make a decision? This may not be your scaffolding. You might tie it, hey, we've got this very regular process, and we're just going to go after every stage. So that would be the other way, right? But like I said, so I look at design time, the planning side. What are all the things we can do? And I've seen some really cool work, people generating stuff on the design and planning side to get code started. And then also seeing people do code gen with it. right? Actually, I've seen it twice now where people did code gen off of requirements for some subset of an application, and they code gen it in a way that we could still debug it. And then the runtime part, I think is the riskiest piece of this. And then you've got analytics, which I think there's a bunch of good use cases for that, to get kind of maybe dig something out you wouldn't have seen otherwise. And then you got to figure out how you're going to do action based on that. And the last one I've got is manipulation. So I hope that's cool. When somebody says, just do it, that makes it really difficult. Let's build a common understanding and work from that. Have a great day.